increasing and decreasing functions. Here's the idea. We have been working completely on the slope of the tangent line. That's what essentially we've been working with. If you think about in algebra, we said that a function is decreasing if I take my pen and I'm going downward as I move from left to right. And my pen's going down, that's decreasing. And my pen's going up, that's increasing. If my pen's going flat, that's constant. So that's how we look at it in college algebra. In calculus, we now have a way of not having to have the graph in order to be able to do increasing and decreasing. College algebra, you have to have the graph. And that's this. If a function is decreasing, I take a point, do a tangent line. Take a point, do a tangent line. And I need a red pen that writes better than that one. Take a point, do a tangent line. Take a point, do a tangent line. What you notice about these tangent lines is on this side, the slope of the tangent is negative. So if I'm decreasing, the slope of the tangent line is negative. If I'm down here at the bottom, college algebra would say this is constant because it's flat. But if I pick a tangent line and I draw a tangent line, what's the slope of this tangent? The horizontal line. So what's the slope of that tangent? 0. The slope of the tangent is 0 for a constant. Slope of the tangent is negative if we're decreasing. And now I'm increasing. College algebra would say it's increasing because your pen is going up. Now if I take a look at it, I notice if I start pulling tangents, the slope of the tangent is positive. We also know that the slope of the tangent is f prime of x. It's the derivative. So f of x is decreasing if f prime of x is negative, or we can say the derivative is negative. F prime of x is increasing, or f of x is increasing if f prime of x is positive, or the derivative is positive. And f of x is constant if f prime of x is 0, or the derivative is 0. So let's kind of apply it to something that looks like this. Here I'm increasing, right? So increasing, and it looks like I'm increasing from minus infinity to 0. Decreasing from 0 to 1. And increasing again from 1 to infinity. Okay, big whoop. But here's what's important. Increasing, decreasing, at this point right here, where I have a maximum, f prime of x is 0. And where I have a minimum f prime of x equals 0. Now we're on a picture, so eventually we're going to take the picture away. So let's take a look at, here's the number line associated with this graph. F prime of x is 0 at 0. F prime of x is 0 at 1. So here is where f prime of x equals 0. I'm going to change pen colors. Now what do we know? Before the maximum, f prime is positive. After the maximum, f prime is negative. So this is f prime. After the minimum, f prime is positive. Now, that would say slope positive, slope negative means that x equals 0 is a, what does it look like it is? Maximum. Right? The little pointy thing is up like this. So positive followed by negative is a maximum. Negative followed by positive is a minimum. So if I were to look at the number line that exemplifies f prime, these two numbers is where f prime of x equals 0, and what they are called are critical numbers. Some books call them values. And something is happening on either side of that critical value. And usually it's either a maximum or a minimum at that critical value. And that's where f prime of x equals 0.